All right, today we are diving into a whole new reality, something that for a century was pretty much trapped in physics textbooks, but is now, right now, completely reshaping our world. We're talking about quantum 2025. So, why 2025? What's the big deal about this one year? Well, it's because the United Nations has officially declared it the International Year of Quantum Science and Technology. And that's not just a fancy title. It's a global signal that this stuff isn't science fiction anymore. This is the moment it all tips over from pure theory into real-world engineering. Think about it. For 100 years, quantum mechanics has been this deeply weird, counterintuitive way of describing the subatomic world. But today, we're using that same weird language to build our future. From computers that defy belief to sensors that can literally see through the ground, the theory is finally something we can touch. Okay, let's get into it. To really get a handle on where this is all going, we first have to wrap our heads around the wonderfully strange rules of the quantum world. So welcome to section 1, what I like to call a world of and. Every single computer, phone, or tablet you've ever used runs on what we call classic bits. And you can think of them just like a light switch. They're either off, which is a 0, or they're on, a 1. That's it. Simple, right? But a quantum bit, or a qubit, is a whole different ballgame. Imagine a coin spinning on a table. While it's spinning, is it heads or tails? Well, it's kind of both, and that's a qubit. It can be a 0 and a 1 at the exact same time. And that wild idea has a name: quantum superposition. It's this power to exist in multiple states all at once that gives quantum computing its incredible muscle. It's only when we interfere, when we measure it or stop that spinning coin, that it's forced to finally pick a side and collapse into a definite 0 or 1. So how does that power actually translate into solving a problem? Imagine a really complex maze. A classic computer is like a little mouse. It runs down one path, hits a dead end, backs all the way up, and tries another, and another. It will get there, eventually, but it's slow. A quantum computer, though, because of superposition, is like water. You pour it into the maze, and it flows down every single possible path all at once. The path to the exit isn't found, it's just revealed almost instantly. Now, if you thought that was strange, you might want to buckle up, because the next quantum superpower is a phenomenon so bizarre it genuinely bothered Albert Einstein. He famously and kind of skeptically called it spooky action-added distance. What he was talking about is quantum entanglement. This is where two particles can become linked, their fates intertwined forever. They essentially act as a single system. What happens to one particle instantly, and I mean instantly, affects the other, even if they're on opposite sides of the galaxy. It's not a signal, there's no travel time, it's just a connection. Let's make that a little easier to picture with the magic gloves analogy. So imagine you have a pair of these entangled gloves. You put one in a sealed box and keep it here on Earth. You put the other in a box and send it all the way to Mars. Now, until you open them, neither glove is left or right. They're in that fuzzy state of quantum maybe. But the second you open your box here on Earth and see you have the left glove, you know in that exact same nanosecond that the glove on Mars is the right one. That's entanglement. So we've got these incredible mind-bending principles: superposition and entanglement. But for decades, actually building a machine that could use them was a massive, massive challenge. So now let's look at why 2025 is really the tipping point. You see, the biggest enemy has always been something called noise. Qubits are unbelievably fragile. I mean, the slightest little vibration, the tiniest change in temperature, can cause an error and just completely wreck a calculation. For years, the problem was that adding more qubits just meant you were adding more ways for things to go wrong. But that is all changing. Late last year, Google's Willow chip hit a huge milestone in what's called quantum error correction. And to understand the scale of this, just look at these numbers. For one specific tricky calculation, the Willow chip took 5 minutes. The world's fastest supercomputer, to do the same thing, would need 10 septillion years. Yeah, you heard that right. This is the moment we prove that quantum computing can actually be scaled up. And you know, this isn't just a one-horse race. There are teams all over the world chasing this quantum dream, using totally different approaches. You've got companies like Google and IBM using superconductors that have to be kept insanely cooled. Then you have others using trapped ions, or even particles of light that, get this, can work at room temperature. Each one has its own set of pros and cons in this race to build the perfect quantum machine. Okay, so the theory is there, the tech is finally starting to catch up, but what's the point? what are we actually going to do with all this power? Let's dive into Section 3, Solving Impossible Problems. Let's start with a problem we can all relate to, something we all hate: traffic. How in the world do you figure out the absolute best route, not just for your car, but for every single car in an entire city, all at the same time? Well, this is what's known as a global optimization problem. And frankly, our normal computers are terrible at it. There are just too many possibilities. But quantum computers, they're built for this stuff. Volkswagen has already used quantum algorithms to optimize taxi routes in Beijing. Major shipping ports are using them to figure out the fastest way to stack and move thousands of containers. This isn't future stuff. It's happening right now. All right, so from logistics, let's talk about security. Now, you might have heard that quantum computers could one day break all our modern encryption, and that's a real concern. But the very same technology offers a way to create perfectly secure, unhackable data. It's done with something called quantum key distribution, and the principle is beautiful in its simplicity. Because observing a quantum particle automatically changes it, any attempt to eavesdrop on a quantum signal is instantly detected. Boom, the spy is caught. China is already a leader here. They've built the world's largest quantum network using their Messier satellite. And beyond communication, quantum sensors are now so sensitive they can find mineral deposits or underground water without ever having to dig a single hole. But maybe the most profound impact, the one that will touch all of our lives, is in health. How can quantum computing truly revolutionize medicine? The legendary physicist Richard Feynman once said something like, "Nature isn't classical. If you want to make a simulation of nature, you'd better make it quantum mechanical." And that's the whole key. For the very first time, we can accurately simulate how molecules behave to design new life-saving drugs in a tiny fraction of the time. We can design brand new materials from the atom up for things like hyper-efficient solar cells. And with these incredibly sensitive quantum sensors, we can detect the faint magnetic fields of our brains or even spot cancer at the single-cell level. Now, with this kind of world-changing potential on the table, you can bet it has sparked an intense global competition. This isn't just a scientific race anymore. It's a deeply strategic one. Welcome to Section 4, the race for tomorrow. Right now, we're really seeing a three-way race take shape. In the US, you have the massive power of the private sector, with tech giants leading the charge in hardware and that critical error correction. China has used massive state-funded projects to become the undisputed world leader in quantum communication. And Europe is leveraging its deep history and fundamental research to really excel in the amazing field of quantum sensing. Each region is playing to its own unique strengths. So I know that was a lot to take in. If you walk away with just 3 key things, let them be these. 1, this is a totally new kind of power. It's built to solve problems that are literally impossible for even the biggest supercomputers we have. 2, it's not a what-if anymore. It's already here working behind the scenes in some surprising places. And 3, 2025 is the turning point. This is the year quantum computing truly steps out of the lab and into our world. You know, for a century, quantum physics felt like a locked room full of bizarre, confusing ideas. But in 2025, that door has finally swung wide open, and it's revealing a world of possibilities we're only just beginning to imagine. So the real question for all of us is, what are we going to discover inside?